Hi everyone. So in 1.3 we're learning about piecewise functions. So a piecewise function is basically chopping off parts of other functions and putting them together on the same graph. So we define it over a specific interval and then we just graph that for that interval. So like in this picture we have y equals x squared, y equals 6, and then y equals 10 minus x, and they're just parts of those functions, not the whole functions themselves. And we also have something called the greatest integer function, and that is a function that just rounds. Okay, so there's two different types. There's the greatest integer function, which is also called the floor function or the ceiling function. So the greatest integer function it rounds it down to the nearest integer below it, whereas the ceiling function gives the integer that is greater, so it rounds up. Okay, so this one rounds up, and this one rounds down. So if you look at the examples there's different notation to it also we should make note of. It could be written with like little brackets at the bottom or the double brackets. Okay. So if we have 2.4, it rounds it down to 2. 2.8 still goes down to 2. So anything, smaller, or it rounds it down to smaller, no matter what it is. You know how normally like 0.5 or up, you round up. This is something completely different. So any of the decimals basically just get cut off and it rounds down. If it's negative, it's still rounding it down because the down would be to -3. Same thing here, it would be down to -4. Okay? Whereas with the ceiling function, which we're not really going to worry about, but I just wanted you to be able to compare them, this one rounds it up. So 2.4 goes up to 3, 2.9 goes up to 3, -2.8 goes up to 2. So it goes to the next integer, where these are going to the smaller integer. Okay, so here's a picture of what the greatest integer function looks like on the graph. Because all of these, like if we have 0.5, we're rounding it down to 0, 0.9 rounding down to 0, but once we hit 1, we go up to 1, that's why it's empty. Okay, and then 1 point anything stays down at 1, once we hit 2, we go up to 2, same thing. Whereas these ones are going down, or rounding up, sorry. So at 0.5 we rounded up, 0.6 we rounded up. Okay, so that's the difference between the two. We're not going to graph this one, we're only going to graph this one. These are also called the step functions too, because they look like steps. Okay, so let's start with our piecewise functions and then we'll get to that crazy step thing. Okay, so for these, all we're going to do is make a table, plug in our numbers, and then graph those points. Okay, so we have to pay attention to the interval that each function is allowed to be in. So here we have 3 different functions, and they're all defined on a specific interval. So for the first one, it says that our x values are less than or equal to -5. Okay, so we're going to make a table with x values less than or equal to -5. So we're going to start with -5. And then we need at least one more point. Since it's linear, we need 2 points. Okay, it's like y equals mx plus b. Since it's 1/5 and I don't want to graph a decimal, I'm going to put in an x number that's going to give out a whole number. So it's dividing it by 5, so the next number would be 10. Okay, and then we can plug in and get the y numbers. So let's set up our x's for everything first. So for this one, it says that x is between -5 and -2. And I know x can't be -5 or -2, but I want to plug them in and see what it's going to look like to know if those points overlap or not. And remember, if it's not equal to, then it's going to be just a hole or an empty circle, like right here, you have this empty circle. That's what we would do for the ones that are not equal to. So I'm still going to plug them into my graph to see where they end up, but we have to remember to put the hole there. So what I do when I write my numbers down on my table, I circle those so I remember that they're going to be a hole when I graph them on there. Okay, and then our last function, it's another linear This x is greater than or equal to -2, so it's not a whole there since it had the equal part, and then I just need one more. Okay, so plug those in the functions, and then we'll get our y numbers. So remember, these will go in our first function, these ones will go in our second function, and these ones will go in our third function. Okay, so if we plug in -5, 1/5 of -5 is -1, minus 1 gives us -2. 1/5 of -10 is -2, minus 1 gives us -3. We plug in -2, plus 4 is 2, 2 squared is 4, minus 3 is 1. Okay, go ahead and pause and try to fill in the rest. Okay, so we get -2, -3, -2, and then 1, -2. Okay, so what we're going to do is we're going to plot each one of those. So remember, when it needs to have a hole, if we didn't put a hole around it, then like if it's not less than, if it has the equal to its part, you just fill it in like a normal dot. Okay, so we have -10, -3, -5, -2. Okay, so those were both filled in. It said everything less than or equal to 5, so I can make an arrow on that side. It's going to keep going. Okay, so now for the middle part, we know it's a quadratic, so it should look like a parabola. We have -5, -2, -4, -3, -3, -2, and -2, 1. Oh, but that was supposed to be a hole. Sometimes like what happens here will happen where the ones that were supposed to draw a hole overlaps with the other one. You know, like these 2 points are the same. So if I leave it for a hole for this one, but this one colored it in, so it still is a point that exists on that graph. If we look here at -2, 1, we have another point. -1, -2. And then this one went forever, so we'll draw an arrow, making it go forever. Okay, so that's it. So we're just breaking up pieces of the graphs. Okay, I'm gonna highlight them too, so you can see. Well, I'm just gonna show you my one highlighted, so you can see what I'm talking about. So it helps to see like. So for this first piece was the green equation, and that was the part that went with it. Our quadratic one was yellow in the middle, and then the last one was orange. Okay. So if that helps you to highlight those sections, then you should do that. Okay, so I'm going to help you set up the table for the next one, and then you're going to do it by yourself. Okay, so for here we have x is less than or equal to -3. So we have everything that's less than or equal to -3. Since it's equal, we're not having a hole there, and then we want all numbers less. So I'm just going to do a couple. I don't know if you remember absolute value. We did that with our parent functions. Looks like a V. So we want to try to get the vertex in our numbers so we could see. Oh, sorry. Oh, sorry. I'm tired. So we could see the V. Okay. So for the next one, we have that our x is between -3 and +2. So we have a hole there at -3, and then we go all the way up to +2. So I'm gonna kind of skip numbers. So -1, 0, 2. All it does is it equals 4. So that one might be confusing. So y equals 4 for those x values. So y is just 4. It's one of those constant functions. It's a horizontal line. Okay, and then for the next one it says x is greater than 2, so we have a hole at 2, and then it's greater than, so since it's linear, we just need one more point, and that would be it. Okay, so why don't you go ahead and fill in the rest of the table for that one, and then we can graph them together, or, yeah, fill in the table and we'll graph them together. Okay, so pause your video. Okay, so here is our numbers we got. We got all 4s there, and then we got a 3 and a 2. Okay, so we know this one should look like a V, this should look like a horizontal line, and this should look like a slanted line. It has a negative slope, so it should be going down. Okay, so -3, we are at +1. -4, we're at 0. -5, we're at +1. -6, we're at 2. And we know it's going to keep going forever in that direction, so we can draw an arrow over there. So that's our first graph. Our middle graph, we know it's just all the numbers 4 from -3 to 2. So at -3, we're at 4, but it can't equal it, so we're going to draw a hole. And then we go all the way to 2. And 2 was equal to, so we color in the hole. Okay, so then for the last graph at 2, we're at 3, but we have a hole there because we already have a point there that keeps it a function. And then at 3, we are at 2, and then there's our graph. Okay, so that's it for that one. We all right? So make sure you write down any questions you have so we can go over it in class. So I want you to do the third one all by yourself, and then we'll go over the graph when you come back. Okay, so pause your video to do the last problem, please. Okay, I didn't highlight this one. I just drew my graphs. So our first one is another straight line, horizontal line function. We have parabola, but it only shows us half of the parabola, and then we have another linear. Okay. So again, make sure you write down any questions, and we'll go over them in class. So let's take a look at our piecewise function, or not our piecewise, our greatest integer function. Okay, so remember it rounds it. So the greatest integer function always rounds down. So don't forget that. So we're rounding down. Okay, so let's plug in our numbers. So we have, I always do a bunch of them to kind of see what's going on. And for this one, I'm going to go up by 0.5s. Sometimes, like the next two, I'm going to go up by 0.25s because there's something multiplying it, so it changes the values. And it gives you a better idea of what's happening. But for this one, I'm just going to go up by 0.5s because there's nothing multiplying to the x. You know, here we have the 2 in front of it. On the bottom, we have a 0.5 inside of it. So it makes more stuff happen, basically. So we need to see more things. I mean, once you get the hang of it and what the pictures are going to look like, you don't really need to do as many points. Okay, so if we put in 0, add 2, we get 2. So round to the nearest integer, round down, would still be at 2. We put in 0.5, we have 2.5. Round down to the nearest integer, we'd be at 2. Put in 1, 1 plus 2 is 3. Round down to the nearest integer, it's still at 3. 1.5 plus 2 is 3.5. We round down, we get 3. You guys see in the pattern what happens? Okay, so if we put in 2, we get 4. It's an integer, so it doesn't have to be rounded. We get 4.5. We round down to 4. 5. 5.5, round down to 5. Okay, so for this one, it's just going up by 1. And that's because there's nothing being multiplied to it. Okay, so when we graph our points, so remember, like the jump is where we put the empty circle. So at 0, we are at 2. Okay, so that's a colored in circle. At 0.5, we stay at 2. At 1, we jump up to 3. So that means here is our open circle, but we jump up to 3 to put our point. So at 1.5, we're still here at 3, but at 2, we end up jumping to 4. So open circle. So once you graph like 1 or 2 of them, you're going to see like what the pattern looks like, and you can just keep making them. I know we didn't find all these points, but it's going to exist there. You know, and then we could do it the other way too. So what ends up happening is this +2 shifted the graph, the normal graph, over. Because if we look back at the parent function graph, to be up at 2, we were up here, so it shifted it over to the left. Okay, so in the next lesson we're going to talk about shifts. So, but this moved it over to the left too, so that's why it's like that. Okay, so let's look at our next one. Like I said, for this one we're going to go up by 0.25s. So 0, 0.25, 0.5, 0.75, 1. Okay, so remember with these though, the brackets are kind of like parentheses or absolute value bars, so you have to do what's inside of it first. So when we plug stuff in, we round first and then multiply. Okay, so if we round 0, we get 0 times 2 is still 0. So if we plug in 0.25 and round down to the nearest integer, it rounds down to 0 times by 2 is still 0. 0.5 rounds to 0 times 2. 0.75 rounds to 0 times 2. Okay, 1 rounds to 1 times 2 is 2. This rounds down to 1 times 2 is 2. 2 rounds to 2 times 2 is 4. This rounds down to 2. This rounds down to 2. This rounds down to 2. This stays at 3 times 2 makes 6. Okay, so for this one, you see that your y values are jumping by 2s, okay, because of the 2. So let's graph that and see what it looks like. So from 0 all the way up to 1, we stay at 0. So from 0 to 1, we stay at 0. But then at 1, we jump all the way up here to 2. And then from 1 all the way to 2, we stay there. And then at 2, we jump up to 4. And then at 3, we jump up to 6. Okay, so as you can see, with the 2 in front, that makes the space between them bigger. So that's it. Okay, so for ones like this last one, with the stuff inside, that means you do all of that and then round that answer. Okay, so I'm going to do the same numbers we did for the last one. The going up by 0.25. Okay, so if we plug in 0, we get 0 minus 1 is -1, which rounds to -1. So let's look at our calculator for this to times our decimal. So 0.5 times 0.25 minus 1 gives us -0.8. So that would round down to -1. 0.5 times 0.5 minus 1 gives us -0.75. So that would round down to -1. Okay, so why don't you try to fill in your table and then come back and I will show you, or we'll do the graph part together. Okay, so welcome back. I hope you pause your video. I don't like when you guys don't. So at -1, we still get -1. We get -1 all the way up to 2, and then we go to 0. And then if you kept going, at 4 is when it jumps up to 1. So those are 0, just 2. Okay, I know you probably didn't keep going because I didn't tell you to, but it helps to see the next number. I mean, you can kind of see the pattern from what's happening here. It took us 2 things to get all the way up to the next number. Okay, so at 0, we're at -1, and we stay down at -1 all the way until 2. And then at 2, we jump to 0, and we stay there all the way to 4. And at 4, I know we didn't do it, well, we did kind of. We jumped to 1. We'd stay there all the way to 6. At 6, we would jump to 2. So once you do a little bit, you can see the pattern and you can keep making the graph bigger. Okay, so that's it. We'll go over more in class. Make sure you write down any questions if you didn't understand a part of it. And that's it. I'll see you tomorrow. Werner out.